to show you how to build slowly changing dimension type 1 and type 2 transformation in Azure Data Factory data flow. What we're going to build today is using one source table and two target table representing the two different types of slowly changing dimensions. To see with the same change happening on the source table, different slowly changing dimension types is going to do different transformations to affect the final target table. So the prerequisite here is that you have been following our GitHub repository modules, and we're currently on module 5. By now, you have already granted your Azure Data Factory access to Azure SQL Database. And here, as you can see, I have already enabled the data flow debug to accelerate the debug sessions. The next step I'm going to go is to go over to the SQL database and create the source table as well as the two targets table as the preparation. If you have been following along, please go to module 5, and in section 0, paragraph 1, you will find the SQL statement to quickly create the objects in database for you. Let me go ahead and open a new query. So with this query, I'm creating my source data set. This one is a joined result set from customer table to customer address table and again to address table, so that in the final result, you will be able to see the customer information, their address information. And here in the where clause, I'm limiting the final result set to only those customers with the last name equals Adams. So let's run this query and quickly refresh the object. Now you'll be able to see that there is a new view created with the name v customer Adams underscore source, indicating the information that I need you to know. With a quick select top 1000 rows, you will be able to see that there are two customers with the last name Adams and their personal information like the cities they're living in, their email address, and phone numbers. With these two rows and any changes that we will make on them in the next sections, it is easy to see how the transformation is done to the target table based on different slowly changing dimension types. So now, if you follow along with the GitHub repository, you will find another two SQL blocks. Let's copy that. So this create table statement is going to create our target table for the slowly changing dimension type 1. Let's run that quickly. And again, with a new query, create our second target table for the slowly changing dimension type 2. Okay, so the difference between these two target tables, as you can see, is in the SCD1 table, we have, in addition to the original view, a new column called last updated for time lineage tracking, and one SID underscore customer Adams. The SID stands for surrogate ID or surrogate key, which is a common practice in building data warehouse dimension tables, so that in addition to the original business key, in this case, the customer ID, we have a second layer of unique key, so that depending on your decided slowly changing dimension method, you will be able to track history changes without losing the lineage to the original business context. And looking at the SCD Type 2 target table, we have the same SID column as the new unique key. We have 3 additional columns called is active, valid from, and valid to. This 3 column is commonly implemented to track the history attribute change of dimension tables, especially in slowly changing dimension type 2 transformation. How they will work together, we will see later. Now, after these 3 database objects are created in the Azure SQL database, we will go back to Azure Data Factory and create 3 datasets representing those 3 objects that we just created. So we will go ahead to the datasets and create our first datasets. The type of this dataset is going to be Azure SQL database. And we will begin with the SQL source. We will use the link services to Azure SQL database. And we're going to wait for this drop-down list to come with the result back. We will select our source table, which is the view custom atom source with the 2 rows as result, if you remember. And we'll hit OK. Okay, we'll repeat the same process 2 times more to create the 2 target table. The first target table is going to be named as SQL target SCD1. Same link service. And this is going to be our first target table. Hit OK. And again for the second target table. Okay, let's hit publish all to make the change permanent. Cool. Then let's create our first data flow to represent the slowly changing dimension type 1 transformation. Let's create a new data flow. And by clicking add source, we'll give it a name. Adams source. And maybe you want to give a description. And let's point to our dataset. And our data flow debug needs to be reactivated before we can test the connection or do the data preview. So now our data flow debug is reactivated. We can test our connection to make sure that our data flow is connecting or able to extract data from our Azure SQL database. Another way to test is under data preview, we can hit refresh button to see if these two rows that we saw previously in Azure SQL Database is showing here as well. Okay, seems to be working. Cool. Remember when we looked at the table definition of the SCD Type 1 target table, we saw a last updated column. That is for time and date lineage tracking. So you always know which record is imported or updated to the target table at what time stamp. That is done in data flow using the derived column transformation. We can give that a name. And it is creating a new column instead of updating an existing one. So we can give it a name. Let's use current time stamp. And in the expression, we have the native function current timestamp. And just to see what this function is returning, we can hit the refresh button in the data preview area. You see it is giving the right timestamp back. Let's save and finish. And for slowly changing dimension type 1, it is really about update and insert. So every attribute change from the source table should be directly updated in the target table. Any new rows coming from the source will be inserted in the target table as well. So before we directly load any new changes from the source to any sync table, we will have to use a row modifier. It's called auto row. And here we're going to define which behavior we're expecting this transformation to do on our target table. And if I make this area a little bit bigger, you will be able to see that we have 4 options: insert, update, delete, or upsert. And here we're only talking about update and insert. If these two cases are all expected together, instead of choosing one of them, or make 2 different streams, one doing each transformation, we can use the upsert condition. And because it is an auto row condition, it will take effect only if the statement defined in the open express builder area equals to true. Whereas in our case, we want to have the upsert effect whenever there is any new rows or updating rows cases happening. So we will give that a always true evaluation. So that upsert case applies as always. As a last step, we will add our sync table. And here, just to make the pipeline visible for other people, let's use the same table name as we used before in the definition. Apparently, we're not allowed to use underscore. And let's link that to our target dataset. So there we have our slowly changing dimension type 1 transformation. This is pretty easy. And let's refresh that to see if these 2 rows coming from the source table would be successfully inserted into the target. You can see we have all the columns defined, and we have additionally here, I forgot to say that we can always check in the mappings pane of the sync table to see if the source and target table are correctly mapped together. And apparently we added one new column called current timestamp. And in the target table, we have that column defined as last updated. So there we need a manual mapping. And the reason we don't need anything mapped for our SID, circuit ID column, is because during the definition of the table here, we defined the SID column as our identity column. That means whenever there is a new row coming from the source, Azure SQL Database can automatically increment this column with 1, so that as long as we have new rows coming from the source, this column from the target table is going to be automatically incremented. So we don't have to map this column. That being said, our transformation for slowly changing dimension type 1 in data flow is finished. And let's see how that happens in action. Let's go back to, first of all, select our target table and run that. As you can see, there's no rows currently. And let's go back and create one pipeline to test this data flow. Let's drop the data flow activity and reference that with our data flow 2. Actually, let me give that a proper name so that we can distinguish that from the later data flow. Okay, now we have referenced our SCD1 data flow. Okay, now our pipeline debug run is finished. And let us go back to the SCD1 type table and to see if there is any change. There is no change, so the data is not loaded. Why? Because we missed one important step in the auto row step. We have selected here that we will expect upsert transformation, whereas in the SQL target sync transformation settings, the default one is allow insert. And this update method should always align with the auto row transformation in the previous step. So this is the one change we have to make. And now let's go back to this pipeline and debug again. Okay, we're obviously missing the key columns. So the update or insert is always based on one key column to the target table. And in this case, our key column is the customer ID. So what it means is that it will compare the source and the target. And depending on this key column, it will then know if there is from the source table any new records, means any new customer ID coming. If that is the case, insert. Or if the source data is containing any existing customer IDs comparing to the target table. If that is the case, then update. So now we should be able to debug our data flow again with our debug session. Okay, now our debug session for the second time is finished. And let's go back to the database and rerun this query. So now you can see our target table for SCD1 is populated with 2 rows coming from the source. And we have the last updated as the timestamp that the data flow finished. And we have 2 SCD identity column populated with 1 and 2. So the next step will be to see if we have a different source data. That means the source data is having some changes. how does SCD Type 1 reflect that change? And for that, we're going to have to run a predefined SQL script. And let me grab that from our GitHub repo. And by opening a new query and paste. So what this script does is to, first of all, move Mrs. Frances Adams from her current address in Modesto to Phoenix. That's an address change. And second of all, we will add 2 new people with the last name Adams as our customers with some predefined values for their customer information. And then to make these 2 new customers also coming with some new addresses, we will have to do something manually there as well. But let's run this statement. And the query is finished. And let's go back to our view, which is our data source, and reselect that. And now you can see, compared to the original state, we have 2 new customer with the last name Adams, one called Anna, one called Michael. They both work for the company Contoso, and they have their own personal information, which is made up. And our Mrs. Frances Adams has now the new address in Phoenix, whereas previously, let me find the query, she lived in Modesto. So this is to mimic a customer table change for a next load or batch of data. And without doing any changes to our data pipeline, let's rerun this data flow again and see how this change from the source is reflected to the target table. Okay, now our debug flow for the change to source data run is finished. Let's go back to the target table, which is here, and see that slowly changing dimension type 1 transformation has done what. Okay, here you can see we have 2 new rows representing Michael Adams and Anna Adams, reflecting all the data coming from the source exactly the same. And now we have for the Miss Frances Adams, also her current living address instead of Modesto, the previous one. So here you can see we have our slowly changing dimension type 1 transformation representing always the current updated information of any dimension attributes. Now let's move to building the slowly changing dimension type 2 transformation. Okay, so with that done, let's do a slowly changing dimension type 2 transformation. The difference between the type 2 and the type 1 is in the type 2 transformation, you always wanted to track the historical change. For example, if we are taking the example of Mrs. Frances Adams' address change, in the previous example, the address change is overwritten. So after this change, you wouldn't be able to know where Mrs. Frances Adams used to live. Where in some business scenarios, that may be the case that you don't care. But in other business scenarios, you wanted to track the historical change. For example, if you wanted to report on sales based on customer address in cities, if you track the historical change and in your report before and after the address change of Mrs. Frances Adams is going to make a difference for 2 cities. So the city Modesto used to have some sales revenue generated by Mrs. Frances Adams, whereas after the change, all her purchases is going to be counted to Phoenix. And in the previous example where this change is not tracked, you will have the report as if Mrs. Frances Adams always lived in Phoenix. So all her historical purchases generated revenue is going to be counted to Phoenix. So this is the difference. Okay, and let's start. First of all, let's build a new data flow. And as previously, let's give it a meaningful name first. And as source, we will reference our existing source, which is called SQL source, I believe. And let's reference the, yes, SQL source. This might be different as in the repository, but bear in mind, this makes no big difference in our demonstration. And as dataset, we'll reference our dataset that is linking to that view. And we'll take the data preview. And now you can see in our data source, we have the changed data to demonstrate you with the potential data source change, which we don't want because we want to have the same start point for the SCD Type 2 transformation. So let's grab the other SQL script that we predefined and execute that. So this script is going to revoke whatever change we have done previously to give the source data view the original state as if nothing happened. And this finished quickly. And if we now select the source view again, you will see we have our original two rows where Miss Frances Adams is now still living in Modesto. Okay, so now with this clean state, let's refresh it again. I think there's some cache problem. Let me, because it is cached in our data flow debug sessions. So let me close that. And reactivate that. Okay, now our data flow debug is reactivated, and let's try again. As you can see, now we have our original data source back, as if nothing, no manual manipulation of the data happened. So we have a clean start. And for this one, instead of only one data source, we can have to use another data source, which is referencing our target table. The reason for that is we wanted to have a lookup every time before we load the changed data to the target table to compare our source and target based on one key column. And that will be our business key column to see if there are any rows that are new coming rows and any existing rows, in this case, existing customers that have attribute change. So in order to make that comparison, we need our existing target table as a reference. So in this case, we're going to reference our SQL targets SCD2 table. And in the source option here is to notice, instead of using the entire table, we're going to have to use a SQL query. And I will paste the query that it will find in the repository. So the main point to remember is that we're giving a where clause on the column is active equals 1. The reason is that in the future data load of this target table, we're going to have cases where for the same customer, there has been some historical change in attributes identified. And with this bit, with this true or false or Boolean column is active, we're going to be able to quickly identify for each customer, for each business key, what is the current value that is active. And for all those values, the value of this is active column is going to be equal to 1. And all the historical attribute changes is going to have the value is active equals to 0. And of course, in this case, we only wanted to compare the new source data to all the existing updating or current value of all the customers, so that we can make the downstream decisions based on that. Okay, with that being said, let's move on. So the next one will be that we further do some transformations for our SQL target table. And in this case, we would first do a derived column. And the purpose for this is to add a hashed existing data. So the purpose here is to create a hash column. And let's give it a name as hash. And for the expression, we will do a hash method, which is SHA2. There are other methods of hashing that we can choose from this expression builder. And the first parameter is 256, which is the default one. And we're going to add in all our attribute columns. So the columns with the value that could change. And in this case, we're going to put everything. So save and finish. So the purpose of this hash column is to quickly identify if any of those changeable attribute column has changed. And the hash function has the effect that all those values within one row as input will give you a unique output as always. That means for all those 6, 7 attribute columns, as long as at least one column has a changed value, the final output of this hash function is going to give you a different value. So by doing this, you can quickly compare if the hash value of the target table compared with the hash column coming from the source table is the same. And as long as there is one case where the customer ID is equaling the source and the target, but the hash column is having different value, that means one of those attributes coming from the source table is changing compared to the existing current value in the SQL target table. Okay, with that said, let's again do a select transformation. And the purpose of this step is to rename our columns so that we're able to easily identify for the following transformations what is from the source and what is from the target. And let's remove this one. And for all those column names that could potentially conflict with the source data, we will add a suffix underscore exists. And because we have up to this point already a hash column to represent all those changeable attribute columns, we only want to leave the business key, the hash column, as well as the 3 additional SCD2 tracking columns for further use. So that means we now could delete all those columns and we'll give a underscore exists to our hash column as well. Okay, up to this point, we are already finished with the target lookup table transformations. Then let's continue to build the transformations for our source table. And as with the target table transformations, let's first create a hash column for that. Add hash new data. Hash, and let's use the same hash function. It is very important that the hash function you chose for the source and target table should always be the same, although you have options to use different hash method. And here, let's try with the same attribute column. Okay. And after this step, we're going to be able to already do the first comparison. Means to compare if from all the source data and with the already existing target data, which are active or current, if there are any new rows or new customers coming from the source. And to do that, we can use a lookup transformation. Let's give it a name with lookup without the one, because it makes no sense. And here we have our primary stream at hash new data. That means the base data is our add hash new data, which is this one. And to look up with our add hash existing, with our rename column data with this one. So that means the two stream is going to be compared using this lookup transformation. And here we're going to have to click on this match multiple rows checkbox. And the purpose is that sometimes when you look up one table to another table, based on one lookup condition, which is defined here, you could have multiple matched rows. And in that case, you're going to have to decide whether you enforce a one row to one row lookup or you're allowing the match multiple rows transformation. And in this case, it doesn't matter because in our simple example, for each business key or the mapping key column that we're going to be defining here, which is our customer key and customer ID, customer ID and customer ID exists, which means coming from the target table. We're always going to have one record back. So having this one checked or unchecked is not going to make a big difference to our demonstration, but for your own use case, it will make a difference. So after this lookup activity, we basically will have two cases. Either there are rows coming from the source that are already there in the target table, means these lookup condition matches. For those cases, we're going to redirect those rows into a separate stream called existing records. And for all other cases where in the source data there are new customers coming, which we cannot find a matched existing customer ID from the target table, for those cases, we're going to open up in another streams called new records. And to do that, we're going to have to add a conditional split transformation. And here, let's give it a name, split customers. And as I said, we have one stream called new records, which maps the condition. Let's open that. Is none, is active. So basically, you can use also other existing columns from the target table. But the point is that as long as the business key, the customer ID, is not a match, it means after you look up for those rows coming from the source, there's not going to be any records coming back with the column is active or valid from or valid to, right? And for all other cases, we're going to give it a name, existing records. Okay. So now we have two streams prepared. Okay, so the next step here is to again differentiate between all those existing records, those existing customers, whether or not any one of their attribute has changed. Because based on the different result, we're going to have different situations for customers, for existing customers that their attributes has not changed as well. We're going to do nothing, right? We're going to keep the already existing rows for those customers in the database untouched. But for those cases where the customer is existing customer, but at least one of their attribute, like email address, first name, last name, living address, was changed, then we're going to do, for those cases, on the one side, insert those new attribute values for the existing customers into the database, into the table, as if they were new coming rows. At the same time, we're going to update those existing records for the existing customers with their existing or old attributes values to archive them. So for that, we're going to have in this area already 3 streams. And let's do that. So then first step is to create, again, another conditional split. And this one, we can name it split hash because it's splitting based on hash value. And for the stream name, let's give it a name as attribute changed. And the condition will be that the hash of new coming rows does not exist or does not equal to the hash exist. That means the customer ID is the same, but the hash value is different, which means the attribute has changed. And for all the other cases, we will have attribute not changed. Easy peasy. And here we can already hit one time refresh to see, here it doesn't matter. It doesn't take effect because we haven't changed the source data yet. So, and after that, first of all, we're going to do nothing for those cases because those attribute has not changed. But for those cases where attribute has changed, we're going to have to build 2 streams, one for update and one for insert. And for the insert ones, we're going to select all those existing rows and insert 2 new rows because we're going to treat them as if they were new coming rows. And we were going to keep all their attributes because we were not sure which of the attribute has changed. So we're going to keep all of them. And we don't need the customer ID because this already equals to the customer ID exists. And we don't need the hash. We don't need the is active, valid from, and valid to because they're going to be assigned together with the new coming data streams. And we're going to not need the last updated because together with other valids from embedded 2, this is going to be updated. And as well, we don't need for this one. And only after we have this insert or a follow-up transformation where we're able to create a new branch so that we can treat the same set of rows with another parallel transformation. And this one we're going to use for our update purposes. And for that, we're going to have, first of all, again, a select transformation. Sorry, this was wrong. What I wanted to do is a follow-up transformation of this parallel stream where we need a select, and we will give it a name, update existing rows. All right, so from these two names, you're going to be able to figure out which stream is for which purpose. And for those update existing row stream here, we're basically only be needing the customer ID as our key column. And we're gonna delete all those. And for those existing values of the customers that they're having new attribute values, we're going to create the 3 helper columns, the is active, valid from, and valid to be mapped with our target table. And we're going to give this a name, updated columns. And first of all, we need a is active. And for all those cases, these values are not any more active. So we're going to give it a false value. And another one with the name valid2. This means the validity of all those rows is going to be set to the current timestamp as of now. So in the future moment, all those values will not be active and will not be valid. And we can achieve that using again, the function we have used before. And the same goes to our last updated column. Of course, you can always use this expression builder and let the IntelliSense write that for you. Okay. And finally, as you remember, as long as we wanted to do some modifications to our sync table, we're going to need a row modifier, in this case, auto row transformation. And we're going to give it a name, update. And the same goes to update if true, like as always. And this last step, we're going to link to our sync. And we're going to give it a name, update sync. Whereas we're going to link it to our SCD2 table. And in the settings, we're going to only allow update in this case. And the update should happen based on our key column, which is the customer ID. And in terms of the mapping, we're going to use the auto mapping in this case. Or if you wanted to check, as you can see, we don't have any mapping to the other columns because we're only doing update operations to those 4 columns, right? To those 4 columns. Everything else stays the same from the target table. Okay, now we're finished with our stream where the customer is existing customer. And now let's build up our new data stream. So from there, we're going to first of all add a union transformation. This is basically to vertically combine two streams of data sets together and map down the column names. And let's give it a name, union. It makes sense already. And this union is union from the new records, which is this, together with this part, insert to new rows. Because if you remember, we specifically have this second parallel stream from there to treat all those new attribute values of existing customers as if they were new values. So we'll have new rows for them created in the database. And after that, we can have an inspection just to make sure that the names of the columns are mapped together. And then we're gonna have to do some housekeeping first, basically because we have two big streams of data coming in and units together, and we want to remove all the columns that we don't need for the following insertion activities. We're gonna give it a name of remove column because that is what we're doing here. And here we can see we still have some exists columns, which we don't need. And in the target table, we don't have a hash. We have all the attribute columns. And the isActive one is coming from the existing table, not from the new tables, so we don't need them. We will create one extra step, derived column to give some default values to them. So now this should be the housekeeped column names that we want for the further steps. And let's add a derived column. This is basically to add the helper columns. Add columns. And here we need a is active, which for all these rows will be true, right? Either it's new customer or the existing customer with the changed attribute values. They're all going to be treated as active. And again, we're going to need a valid from column. And again, that means those values invalid from the time point where the data is inserted. So current timestamp is the function we need. And the same goes to valid 2. And here, depending on your preference or the policy in your company by defining or data warehouse policies, you could have different values. And here in my demonstration, I'm going to use this format. Okay, I'm going to use a year 9999, month is December and 31st, and hour, minute, and second. So this is going to be treated as the infinite timestamp that the current value is going to be weighted to until they're changed again in the future. Then this one will be set to the time point, to the timestamp where the change happens, right? Save and finish. And lastly, we will need a it's not existing, but last updated for the timestamp tracking, which should have the same value as the current timestamp. Okay, cool. And then finally, we have all the transformation defined. We're able to insert those rows into our target table. And as happened just now, we will need an auto row transformation. And here we will tell ourselves that this stream is for insertion. And we will allow only insert under the condition of always true. And finally, we can hook up with our sync, give it a name, insert sync, right? And the data set is going to be our SCD2 target table. And regarding of settings, here we're allowing insert, and just to compare, we're only allowing update here. And the very important thing is here in the mappings. If we unclick the auto mapping, we'll be able to see if all the column names has been successfully mapped. And we can delete this because, as you know, this is identity column. This will be automatically incremented and inserted. Cool. And up to this point, let me first of all have a refresh. And because we haven't done any changes to our source data yet, this insert sync should be the only stream that all this data comes through. Right here, you can see right. And if I click on the update sync, there should be nothing coming out. As anticipated. Cool. Then let's first of all go back to the pipeline, and this time let's use the same data flow activity, but switch from SCD1 to SCD2 and do one debug. With that, we will load the current 2 rows from the source view to our SQL target SCD2 table. Okay, now the debug run is finished, and let's go back to our SCD2 target table and select 1000 top rows. And you can see there's 2 rows of record with the last name equals Adams has been successfully inserted. We have for all 2 records currently is active equals true. They're weighted from the current timestamp and weighted to an infinite future timestamp, where the last updated is equal to the weighted from, and we have for each record a surrogate ID column value. Okay, the next step is that we do the same manipulation that we did during our demonstration for the Slow-Originating Dimension Type 1 transformation. And let me quickly grab that SQL script again from the GitHub repository. Okay, found it. Let's use that. Oh, yes, it is actually here already. So let's run that. Okay, we have, oh, sorry, this is the original one. And let's use a new query. Okay, this one is the manipulation script. Let's run that. Okay, it's finished. And if we now select the top 1000 rows from the source table again, you can see Miss Francis is moving to Phoenix as a change. J Adams has no change at all. Everything stays the same. And we have 2 new customers with last name Adams, Michael and Anna, and they have their own data. So without any changes, let's run the debug flow now for the Slow-Originating Dimension Type 2 again and see what happens. Okay, now the debug run is finished. And let's go back to the database and let's query our SCD Type 2 target table again and see what happens. As you can see, now we have 5 rows comparing to our SCD Type 1 target table. We have 1 more row. And the difference here is that if you look at Mrs. Frances Adams, we have 2 rows. One recording her previous living city, Modesto, and the new one representing her current living city, Phoenix. And if you look at the vetted from and vetted to, this is her previous record, where the vetted to ends at the time where the new records is coming into the system. And from the last updated, you can also see that this previous record was not touched. And now we have last updated of the current timestamp where the data was inserted. As of for Anna and Michael Adams, these two are treated as if they are new customer, new records. So all the beta 2 stays the same. But the major difference is comparing to SCD1 is that we have our historical record to track. And let's say if we have any fact data recording each and every customer, what did they buy on which day, we'll be able to track back during this time Miss Frances Adams bought something that will be categorized into the sales in the city Modesto. As of where in the future, anything she buys will be categorized or added to the sales revenue belonging to the city of Phoenix. Great. So here we are finished with our SCD2 Type 2 transformation. We have done a tremendous job here. Look at what we have achieved together. This is one of the most difficult to understand concept in data warehousing projects. As long as you can master this technique, you can call yourself a business intelligence expert. Congratulations, and thanks again for your attention in this video, and I hope you learned something today. Let's not forget to publish all the changes we have done. And have a nice day. Bye-bye.